Okay, we have decided we're doing a statistical study. We have decided how we're going to sample, to get our sampling people so we can then start our data collection. So how are we going to collect our data from the sample that we decided on? From the people or cans or whatever we're doing. How are you going to get your data? So we could use a simulation or a dry lab approach, run it all kind of a simulation on a computer or a mock-up, or there are quite a few extensive simulations going on in all senses of science because they can't actually do something. So especially like crashes and things like that, they simulate things to see metal strengths and things like that, okay? Or do you just want to observe? Do you want to observe and measure the individuals in such a way that doesn't change the response? You're just writing things down about what they're doing, how often somebody does something. So you don't really ask them, you just observe what they do. You could also design a study. You got your people, and then you divide your people into control group and a treatment group. The control group is the people that, if it's people, deliberately don't get the treatment, and so you can keep them as kind of a baseline or control to compare them to the people that get the treatment, okay? So an experimental study is a treatment is deliberately applied to parts of the individuals and the responses are observed, okay? The independent or explanatory variable is what's being manipulated. The dependent or the outcome you get is the variable that is studied to see if changes are significant because of the manipulation, okay? The control group was not given the treatment. This is also used to figure out if there's something else going on, a confounding or lurking variable that may be the underlying cause of some sort of change versus the treatment group that got the treatment. A placebo is when somebody receives no treatment but incorrectly believes that he or she is in fact receiving treatment, and usually with favorable results. So if you're giving people like a supplement and it makes them feel great, and they can talk themselves into thinking that they got the treatment and they feel great, so that's a problem. You also have the Hawthorne effect, where the subject acts differently than they normally would because they're in an experiment, which changes the studies there. The double blind is when neither the subjects, the treatment receivers, nor the observers, the treatment administrators, know which subject is actually receiving the treatment. So the researchers plan the experiment, make up the dummy pills that look like the other pills, give them to the instructions and separate them out and give them to the administrators, and then the treatment receivers get their drugs and nobody knows. That way the observers aren't biased either. Okay, they're just straight observing what they see. It makes a little less problem with the other placebo and Hawthorne effects. Blocking and matched pairs are ways of grouping subjects, control and subjects in each group, just sort of a little more closely aligning each members in the groups. Replication and sample size are very important. Obviously, the larger size, the better. One of the problems these days is you have medical researchers doing their own research, saying all kinds of things about how it happened, but they really only tested 3 people. So those 3 people, that's what happened, but that doesn't mean what 100 people would happen. So you need to test 100 people. And then not only you, but if you say this works, then somebody else needs to try with 100 people and see if they get the same results. That's why this kind of thing takes time to get quality experimental results, larger and replication. Okay, that kind of stuff takes time. I know one of the problems is pharmaceuticals don't have to report when they have a bad test, and they keep doing more testing until they get a good test, and then they report that one. So it's important to have independent testing and repetitive testing to make sure who's ever pushing this thing um, can be relied upon to have a good test result. Okay, actually good. Take a survey. That's a common way to do things. You can do it by phone or interview or emailed or types of questions. Yes, no, open-ended. What do you think about this? What do you feel about the climate? Whatever you want to say. And then they let the people talk and say whatever they want. Or they just ask them very detailed yes, no responses. Or they can make a scale up. How do you feel about this? Strongly agree, disagree, that kind of thing. But there are some problems with the survey. Obviously, if it's a mail-in or an email, you only get so many response, and so it's considered an undercoverage because everybody you sent them to didn't respond, or they didn't respond truthfully, or they, didn't remember correctly what you're asking them. And you have to watch your wording. Like if you said, "Is it true that milk is fattening?" That like puts it in their head that it is fattening, or you should be concerned about it might be fattening. So be careful how you word your questions. Vague wording can lead to different interpretations. Like how often is often? Do you watch TV a lot? No, I don't watch TV a lot, only about 12 hours a day, right? Do you have a lot of cats? No, I only have 12 cats, right? So it's an odd thing. And then you have interviewer influences, tone of voice, body language, dress, gender, ethnicity. Sometimes when the manufacturer of a product is asking the questions, they can ask it in such a way that it manipulates what your responses are. If you have your teacher asking you about things, you may be all intimidated and answer a different way than if a friend asked you something, right? A peer asked you something. Voluntary responses, we mentioned that people who have stronger feelings are more likely to respond. A lurking variable has an influence over the data, but the information was not collected. They found out when they were first trying to figure out mileage of cars. They didn't used to have city mileage and country mileage or interstate mileage or whatever it is, the two categories, because they would just test the car and they were getting such different numbers that they had to finally break it up and say, okay, we need a mileage for inner city driving and then a mileage for highway driving. So that way you get mileage now on every car two different ways because of the traffic congestion. It affects mileage results. Confounding variables, a different variable influences cannot be distinguished from each other. Students may be taking easier classes due to time constraints, not to bring up their GPA. So we think about those things all the time in the college because we have people that take faster classes versus long classes, what time of day they take classes and why. There's a lot of variables moving around for us to plan classes for them. So we try to figure that out. It doesn't always work. Identifying possible errors. Sampling errors is something that we're actually going to measure in Chapter 7, the extent to which the sample does not match the population. Something happened. Either when we got our random sample, it didn't turn out to be great. Okay, something when we pulled the people from the population, something went wrong. Undercoverage results in omitting population members from the sample frame. So if you're the census people, you need to go under those bridges into the shelters. You need to find everybody. And if you have people overseas on vacation, they never got the thing, you're missing people if you're doing a population. Non-sampling errors, you added things wrong, you can't read your own writing, you backwards numbers, you didn't sum them correctly, biased in your questions, poor sample design, that kind of thing. Remember, if you're ever doing a survey or asking questions, you need to obtain permission before you do that. Some people get really upset about that kind of thing. Also, there's uses and misuses of statistics. Really good examples in the textbook. I don't have time to go over them here, but people do manipulate statistics to get you to buy things, right? Sometimes they use statistics to prove things that are true when they're not, to get our attention, to evoke fear. It's a good topic to read about, and if I have time in class, I'll be going over it. As well as, it's a really good example on page 23 about today's cigarettes and vaping. They did a good study with that. For our purposes, just right now, which technique is gathering data would you feel is appropriate for the following studies? Just from these choices, just from sampling, experiment, simulation, or census. To study the effect of stopping the cooling process, obviously we're going to do a simulation for that. Okay. Study the amount of time the students taking a full course load spending watching TV. I don't know. What do you think? I mean, it sounds very general. We're not going to ask all college students. We're definitely taking a sample. There's no way we can get everybody, so I think in this case they're just looking for sampling. Okay, out of my 4 choices up here. Study the effect of bone mass on a calcium supplement given to young girls. I put this one in there because they actually did this as an experiment, okay? Excuse me. There are times where they get approval to do things if it's does no harm and only benefits and things like that. They get permission to do certain things that are deemed safe, obviously. Study the credit load hour of each student enrolled at your college. Credit load hour. That is something we could look up on a piece of paper at the end of the drop add period this semester. That's a fact, and we could get each one. So that would be a census, right? Census is a population. Census is all. All right, note any potential issues with the following studies. A uniformed police officer interviews a group of 20 college freshmen. She asks each one his name or her name, and then if he or she has used an illegal drug in the last month. Gee, what's wrong with that? I'm thinking interviewer, what they say up here? It was on the other page. Interviewer influence, okay? Whoops. Sorry about that. Truthfulness, faulty recall. They're just not going to tell them what they want to know. Jessica saw some data that showed up where more low-income housing have more homeless people. Does building low-income housing cause homelessness? We have absolutely no information on that. Basically, it's a conversation about correlation versus causation. With statistics, all you're supposed to do is find correlations. And then maybe you can infer connections. But that's up to you. The statistics is not going to show cause, okay? Survey about food in the student cafeteria was conducted by forms available to pick up at the cash register. The drop box for the completed form was outside the cafeteria. So you have to be motivated enough to pick up a form. Chances are, and then putting the drop box way over there, either you don't want to know or you want, you're going to get strong opinions. So I'm thinking whoever picks that up is mad about something, maybe. This was awful. We want to write it down, and we're going to find that Dropbox and put that in there. Can't really picture people going, wow, that was so amazing. I want to make sure that they serve that again. So that might be something they might do. Let's think positively for a minute. That might not be the best way to get all opinions about how the food is in general, but certainly the strong ones. So that was voluntary response issues? Voluntary response. performance issues. Extensive studies on coronary problems were conducted using men over the age of 50 as subjects. So they found out that in the past, a lot of experiments and studies were done with just men, and that, gosh, women don't seem to be the same. So they made assumptions about men being the proper choice. These days, they totally do different things, but they have to make assumptions for children because they often can't test on children. So it's a tricky thing, but make sure your underlying assumptions are not causing issues with your sample, right? Because that would cause a what they call it on the other page, a sampling error, right? If you're just using men over the age of 50, so sampling error. Sorry for the handwriting. Discussion about choosing data collection techniques. So from least controlled to most rigorously controlled. So the easiest thing to do is send out a survey. Maybe it would be a little easier to like directly observe to be more accurate, right? But then to be really stringent and rigorous, you want to set up an experiment. It takes more effort to do that, but you get a more precise and reliable result. Most reliable to least reliable, right? Same, go back the other way. Okay.